All right, we're going to look at the basics of the trig derivatives. So we're going to start off by using the definition of derivative, the formal definition, which is the limit h approaches 0 of f of x plus h minus f of x all over h. And what we want to do first is find the derivative of the function sine of x. So before we start, there are two basic limits that we're going to use, and we can find these by just graphing the function and taking a look and see, but I'm just going to go ahead and give you these limits. The first one, the limit as x approaches 0 of sine of x over x is equal to 1. And the other one is the limit as x approaches 0 of cosine x minus 1 over x. That's equal to 0. Okay, now let's go back and see if we can figure out what the derivative of sine is. So what we're going to do is use the basic definition of derivative and apply it to sine. So we're going to take the limit as h approaches 0 of sine of x plus h, so we're just replacing f of x with sine of x, minus sine of x all over h. All right, at this point we're going to try to evaluate this limit. We can't legally sub in a 0 for h in the denominator, so let us use some trig identities and mess with the numerator a little bit. The sine of x plus h is a sum of angles identity, and that goes like this. The sine of x plus h is the sine of x cosine h plus cosine x sine h. So we just expanded that first part by using that identity, minus the sine of x is still on the end over h. Now we're going to take that numerator and rearrange the terms a little bit. Take that sine of x, which is on the end, and move it into the second position. So we have the sine of x cosine h minus sine of x, which we just moved, plus cosine x sine h all over h. At this point, we're going to take the first two terms of that numerator and factor out the sine of x, the sine of x times cosine h minus 1. And then we have on the end cosine x sine h still. Well, believe it or not, we're getting close to what we want. Now, taking a look at that numerator and the denominator, we're going to split this fraction up into two parts. So still, we're trying to find that limit as h approaches 0. So we got sine of x times cosine h minus 1 over h plus, again, I'm splitting this into two fractions, cosine x sine of h over h. So I just divided the fraction up into two individual fractions. And now looking at that, remember we're trying to take the limit as h approaches 0. Well, if you notice, this part of it corresponds to that limit. So that is equal to 0, and this part of the limit corresponds to this limit, which is equal to 1. So after we evaluate those limits, see if I can scroll down here a little bit. So cosine h minus 1 over h is equal to 0. This drops out. Sine of h over h is equal to 1. So after we take the limit as h approaches 0, we're left with one thing, and that is cosine of x. So what that shows us is that the derivative of sine is equal to cosine. Now that is on the formula sheet, so you don't have to memorize that, but after you use it a few times, you're going to know it anyway. So let's do some quick examples. Let's say f of x equals the sine of 2x. If we want the derivative of that, as you know, we have to use the chain rule when we have something other than a regular x in the parentheses. So the derivative of sine is cosine, so it's going to be the cosine of 2x multiplied by the derivative of the inside, or the derivative of the parentheses, which is simply 2. Final answer, 2 cosine 2x. All right, let's take another quick example. Let's say we want the derivative of the sine of x squared. Well, same thing. The derivative is going to equal the cosine of x squared multiplied by the derivative of the inside, which is 2x. And we can rearrange that and write that as 2x cosine of x squared. All right, let's take a look at one where some students get confused. Let's say the f of x equals sine squared of x. Well, what I say to do is we're going to call ourselves beginners and say, well, what that actually means is a function. It's the sine of x squared. So that's what the notation means when you put the squared right after sin. It means you're squaring the whole function. Now if we want the derivative, remember, start on the outside and work your way in. So we take that 2, which is the power of the function, drop it down front, decrease the power to a 1, which we don't have to write, but I'll just stick it in there. And then take the derivative of the inside. The derivative of sine is cosine. And the final answer is 2 sine x cosine x. Those are 3 basic examples, and once you get that down, you can take the derivative of sine of anything, really, and then all the other trig properties and tricks apply to sine as they do to any other function. But while we're at it, let's list all the derivatives. So the cosine of x, its derivative is negative sine of x. Tangent of x, its derivative is secant squared of x. Cotangent of x is equal to, its derivative is negative cosecant squared of x. Notice all the cos, cosine, cotangent, their derivatives are negative. Secant of x, its derivative is secant x, tangent x. And cosecant x, here's that trick again, that's going to be negative cosecant x, cotangent x. And you can also see a relationship there. Tangent is secant squared, cotangent is negative cosecant squared. So the co goes with the co in that case. Same thing here, cosecant x goes with negative cosecant x, cotangent x. So there are all your trig derivatives that you're going to need to use. So any problem that involves one of those trig functions is going to work basically the same way. Let's take a look at a couple quick ones as I scroll down here. Let's say we had the secant of 5x squared. That's our function, and we want to take the derivative. So the derivative of that, derivative of secant, you could look at your list of derivatives, but as I said, you'll learn them after you do them a few times. Secant is secant tangent, so it's going to be secant of 5x squared times tangent of 5x squared. And again, chain rule applies, so you go to the inside or the parentheses, you take the derivative of that. 5x squared, of course, is 10x. There's our final answer, which we would probably write as 10x secant 5x squared tangent 5x squared. Done. All right, let's take a look at something a little bit different. Let's do a product. What if we had f of x equals sine of x times tangent of x, and we want its derivative? Using the product rule, the first function is sine of x times the derivative of the second, which is secant squared x, plus the second function, tangent of x, multiplied by the derivative of the first, which is cosine x. And there's the answer. It's that simple. So as I said, once you have the list of derivatives in front of you as related to the trig functions, you just use the same rules that you already know as far as taking derivatives. And that's a brief summary or a brief introduction to how to take derivatives of the trig functions. Done.